concurrency control technique. Right? Okay, so if you guys ready, then I think we should start. Okay, concurrency control technique. Okay, all right. So we look at this concurrency control technique topic, subtopic. Okay, sorry. Take a look at here. Conservative approaches. Okay, the delay transaction in case there are conflict with other transaction. Okay, it's locking or timestamping. The other one is optimistic. Okay, so methods assume conflict is rare and only check for conflicts at commit. Okay, when you commit your transaction, then they will look at the conflict. Okay, see this one is the versioning or multi-version. Right, so let's take a look at the next page. We look at locking. Okay, so this one is most widely used approach to ensure the serializability. Okay, and there are two types of lock here. They can look here. The first type is share lock or read lock, and then the other one is the exclusive lock or write lock. Okay, so this read lock, okay, is a transaction with a shared lock on a data item. You can read the item but not update it. Okay, you can only read but not update. Okay, so it used when just reading to prevent another user from placing an exclusive lock on the record. Okay, and for the write lock, okay, this transaction with exclusive lock on a data item, okay, that can both read and update the item. So for the first lock, they can only read, and the second lock, the write lock, okay, they are able to read and update the item. Okay. Let's take a look at the compatibility metrics. Okay, there are two user requested. Okay, so user one, okay, share read lock or exclusive with write lock. Okay, so you can see here share read lock for user one, and this one is for user two. Okay, if both are share lock, the lock is granted. Okay, when user one is in read lock, okay, the user two with the write lock, the user two, this second user will have to wait. Okay, if user one is in exclusive or write lock and the user two is in this type of lock, share lock or read lock, then the user two have to wait. Okay, but if both of this user one and user two are using this type exclusive lock, okay, still user two have to wait. Okay, because user one is the first one. Okay, so any numbers of users can hold a shared lock on the same item. Okay, but only one user can hold an exclusive lock. Okay, okay, only one can hold the exclusive lock. All right. Okay, hold on guys. Okay, okay, so let's go to the next page. Okay, two-phase locking, okay, or 2PL, okay, short form for it. Okay, so this transaction follow the 2PL protocol. Okay, if all locking operation proceed first unlock operation in the transaction. Okay, so the two phase of every transaction will be a growing phase, and the other one will be a shrinking phase. Okay, so the growing phase, okay, it acquire locks, okay, without releasing any locks. Okay, so you get the lock without releasing any lock. Okay, and shrinking phase, okay, it release the locks without acquiring new locks. Okay, let's see here. You release the lock, okay, without getting any new lock. Okay, but for growing phase, okay, you acquire lock, you're getting a lock, without releasing any lock. Okay, and these are the chart, okay, for growing phase. These are the shrinking phase going down. Okay, so the more locks you acquire, okay, going up. Okay, going up is how many locks you acquire. Okay, and shrinking phase, okay, you release the lock. Okay, so let's go to the next page. Okay, preventing loss update problem using the two-phase lock. Okay, so we have number 1 and number 2. Okay, and then we start the sequence timing. Okay, so you can see over here on this T1, okay, x is equal with x minus 10, and T2 over here is x equal with x plus 100. Okay, transaction start with the T2. Okay, so T2 will begin the process first. Okay, so we can see the balance is 100. Okay, and the begin transaction for T1 occur after T2 start the transaction. Okay, when the T1 start the transaction, the T2 already have in this situation, which is right lock. Okay, right lock. Okay, so for T1 in this period of time, the T3, okay, it's going for right lock. Okay, we're going to lock this balance. Okay, so look what happened on this case for T2. They already have in this situation. Okay, read. Okay, they read the balance. Okay, and what happened in T1? They have to wait. Okay, for this thing to be done. Okay, so they will read the previous balance is 100. So when they putting the transaction, they're putting 100. Okay, and this T2 will begin all the transaction first. Okay, just in the time frame, okay, you can see that T2 is the one that starting the transaction. Okay, so they read the balance, they insert the balance, and they write. Okay, and T2 have write the balance, then you can see the balance is 200. Okay, but in this situation for T1, okay, they still in waiting process. Okay, after this T2 commit the transaction, okay, commit to unlock. Okay, and you say they give room for the others to do changes. Okay, so after this commit and unblock, okay, then T1 will begin to read the balance. Okay, and then the balance is equal to this line, okay, which is T2 already done the transaction. So when T1 look at the balance, okay, and see the balance is daily, okay, 200. Then the transaction in T1, which is minus 10, will begin here in the T9. Okay, and after that, of course, T1 will commit the transaction. Okay, so this is how they do the prevention. Okay, while the other one do the transaction, the other one have to wait for a period of time until this person commit the transaction. Okay, so let's take a look at the next page. Okay, preventing uncommitted dependency problem using 2PL. Okay, the other one is commit. This thing, what happened is roll back. Okay, so take an example of what is T3 and T4 are going to do. Okay, so T4, okay, as usual, they will add 100. For T3, they will deduct 10. Okay, so transaction begin with T4. Okay, the current balance is 100. So when T4 starting to do the transaction, it will go this phase. Okay, is right lock. Okay, because we're going to modify the balance number. Okay, so going to write, modify this balance. So these are the symbol for balance. Okay, they read the balance and then they go into the equation. Okay, they're going to add 100. Okay, then they will write the balance, but this P4 doesn't commit anything. Okay, it didn't commit. Okay, even though this P3 begin the transaction in this period of time, the T4 time. Okay, the fourth period. Okay, starting the begin transaction over here. So when it going to modify the balance, okay, what happened here? It will wait. Okay, it will wait until this thing commit or uncommit. Okay, so we go for rollback, then this T3 will going into the read balance. Okay, so the balance will be still in this balance lah. Okay, balance X. Okay, so T3 will begin transaction, which is to deduct by 10. And then to deduct by 10, we write C 90, and then last thing for T3 they commit the transaction. Then you can see the balance is 90. Okay. So let's say this one, let's say this thing doesn't happen. I can say rollback or committed. Okay, let's say it's rollback like this one. Okay, and this T3, okay, doesn't wait for this commit or uncommit action. Okay, what happens when they read the balance? Okay, when they read the balance, it show it's 200. Okay, and when they do the deduction of 10 whatsoever, okay, deduct by 10 and then write the balance, commit the transaction, it will become 190. Okay, if this T3 doesn't have this waiting period. Okay, same goes to this one. Okay, same thing. So okay, so let's go to the next slide. Okay, and this other inconsistent analysis problem to recap. Okay, so this one is occur when a transaction reads several values. Okay, but second transaction updates some of them during the execution first. Okay, so what does it mean here? So let's take a look at this time frame. Okay, this transaction. Okay, so we have T5 and T6. Okay, and what they're going to do is for T5, okay, X, okay, balance of X, they will deduct by 10, the balance of Z, they will end at 10. This is what the T5 is going to do. And for this T6, okay, we're going to sum all the balance of X, Y, and Z. Okay, and the transaction begin from T6. Okay, T6. Okay, so yeah, begin the transaction. Okay, they will look at the sum is 0, and is 0, and then when you read the balance, okay, read the balance. Okay, you can see here. Okay, T5. Okay, they begin the transaction a bit late, but straight away we're going to read for the balance. Okay, balance for X. Okay, balance for X. Okay, and at T6 over here, it appears to look at the same balance. Okay, they read on this balance X. Okay, which is something 100. Okay, so T5 here, after it read the balance, okay, they will straight away do this transaction, okay, which is deduct 10. Okay, deduct 10. And for this transaction, this T6, okay, what it did is, okay, to do this transaction of sum, okay, they will sum, okay, the previous sum, okay, which is 0 lah, of course it's 0, okay, plus with the balance, okay, 100. Okay, 100. Okay, suppose if we look carefully over here, okay, the sum plus balance is 100, and for this situation, okay, the balance X is 100 deduct by 10 is supposed to be 90. Okay, the sum is 100, but the balance is still 100 over here. Okay, and when you write over here, write the balance on this time frame T5, okay, on T5 over here, okay. If we write the balance, and you can see the balance up, the balance X reduced by 10 and become 90. Okay. You can see over here, this one's supposed to be 90. Okay, supposed to be this one have to be done when this thing open up. Okay, so after this one, the sum, okay, 100 over here, okay, then it will read the balance Y, okay, 50. Okay, so this one they are done with the modify, get the right, okay, balance X, and then they read the balance of Z, 25 over here. Okay, so after this P6 and read the balance Y, then you put in the sum. In the sum equation. So sum will be sum plus balance. So if this one's supposed to be, okay, according to this P5, if we look at P5 only, okay, the sum will be 100. Okay, plus with the balance 5, 150. 100. But now it become 150. Okay, if it's already 19 plus 50. Okay, but that one will be the end. Okay, we're going to see what happened in the end. Okay, sum balance. Okay, and then balance Z, okay, is plus with 10, okay, from this section in P5. Okay, so in this P8 period, okay, it will write the transaction, okay, plus 10, okay, plus 10, then give the P5 over here. Okay, and see every time it's right, then it will increase or decrease according to the transaction. Okay, for X, okay, it will happen in right here. Okay, and this one also happen at the right over here from this one. Okay, that's the paper. And then they commit. Okay, so when they commit, everything will be committed lah. Okay, minus 10 and plus 10. Okay, and but when we look at this one, okay, when they read the balance of Z, it already becomes 55. Okay, and the sum plus with the balance Z, 55, will become 185. Okay, so they commit, and these are the results that we are getting. And this number that we are getting is not tally. Okay, it's not correct. Okay, so this transaction is flush. Okay. Okay. So the problem can be avoided by preventing T6, okay, T6 from reading balance X and balance Z until T5 completed the updates. Okay. So I believe you guys get what I mean. Okay. This is inconsistent. Okay. Supposed to be that this T5 to finish everything, commit all this transaction, then T6 will do its transaction. Okay, if it's not, then this thing will be happen. Okay, sum is not tally with the balance. Okay, so if you look carefully, when you 90 plus 50, you get 140 plus 35, you get 175. But what we do get over here in this sum is 185. Okay, this is not tally. Right? So I believe you guys can understand with this one. Okay, and let's look at the next page. A deadlock. Okay, so it's an in-case that may result when two or more transactions are each waiting for locks held by the other to be released. Okay, so this is a deadlock. So meaning to say we have keep two of this user, okay, in a waiting list. Okay, we keep on waiting until there is no end. Okay, so you can see over here. Let's take a look at this time frame. Okay, and consider this is user 1, this is user 2. Okay? So user 1, they're going to deduct the x by 10 and plus the y by 20. And for this user 2, they will add 100 for y and 70 to x. Okay, and the transaction begin with the user 1. Okay, they will write the log balance x. Okay, so when this user 1 in this moment write log and user 2 is starting to begin the transaction. Okay, so this user 1 will start to read the balance of x, and this moment also user 2 starting to get the key, okay, to write the balance y. Okay, so they're doing the y first. Okay, so this one they're doing the x, so they do the transaction of y. Okay, see over here. So balance x. Okay, so they're starting to deduct the this number 10. Okay, and this moment also for user 2 it will start to read the balance of y. Okay, then at T5 we write the balance x. We modify x. Okay, and at this moment also at user 2 they were starting to do the transaction by adding 100. Okay? So when this user 1 get into the other transaction of y, okay, we're going to get the key, take the key to modify this balance y. What happened over here will wait. Okay. Why? To get the key, it needs to wait because in this transaction, user 2, they haven't done anything. Okay, they just in the state of writing the balance of y. Okay, at the same time, user 1 trying to get the log. So when this user 1 trying to get the log, okay, and it reads that user 2 is going to modify the balance y, user 1 will be in the waiting state. Okay, waiting for this to be done. Okay, but once they write this one, they start away getting the log for balance x. Okay, but just because this one haven't commit anything yet, okay, see there is no commit line, commit all these modified things. Okay, what happened? This user 2 also waiting for user 1 to commit its balance x. Okay, so they're going into this waiting step. Okay, so both of these users are in this waiting step. So when will it be end? Okay, there is no end for this one. They'll keep on waiting. Okay, so this scenario is what called deadlock. Okay, because they are waiting for each of these user releasing their key. Okay, that's because in this is what we call it deadlock. There's no commit. Okay, so that is deadlock. Okay, so 3 general techniques for handling this deadlock. Okay, the timeout. Okay, like I say, will be given a time frame. Okay, in 5 seconds, 10 seconds, and then if there is no transaction or no releasing key, then it will stop. Okay, and then the other one is deadlock prevention, and then deadlock detection and recovery. Okay, so we look at the times out. Okay, so the transaction that request log will only wait for a system defined period of time. Okay, like I said just now, okay, there will be a period of time for waiting state. Okay, if the log has not been granted within this period, okay, the log request times out. Okay, it will be aborted. So the database management system abort and automatically restart transaction. Okay, so they will begin back the transaction. They will go back. So there will be no transaction happen. Okay, so that's the technique of timeout. So deadlock prevention. Okay, so the database management system looks ahead to see if the transaction will cause a deadlock and never allow deadlock to to occur. Okay, and could order transaction using transaction timestamp, which is wait and die, or wound and wait. Okay, so the wait die. Okay, so we look at this first condition. Okay, if timestamp of T1 is smaller than the timestamp of T2, then allow T1 to wait for T2 to lock. Okay. And then second condition, if the timestamp of T1 is larger than the timestamp of T2, then T1 is aborted, rollback or restart. Okay, rollback and restart will be the same things now. Okay. So we look at this this thing over here, transaction 1, transaction T2. Okay. So this one is the older transaction, okay, and this one is the younger transaction. Okay. If the timestamp of T1 is smaller than the timestamp of T2, then allow T1 to wait. Okay. But if the timestamp T1 is larger than the timestamp of T2, then T1 is aborted. Okay. Yeah. So you look at the timestamp over here, this one is much more this one is much more larger. Okay, much more larger. Larger because just look at the time they begin the transaction. Okay, this is 23, 50, 56, this is 23, 51, 12. Okay, now you can see that T2 is aborted because the timestamp is larger. Okay, the transaction number second, transaction T2 lah. Okay. If this T1 is smaller than this T2, okay, T1 is smaller than timestamp of 2, then allow T1 to win. Okay, because this one is smaller, this one is bigger. Okay, so T1 will win. But if the T1 is larger than the times of T2, then it will be aborted. Okay, just like that. Wound and wait. Okay. First condition for wound and wait, if timestamp of T1 is larger than the timestamp of T2, allow T1 to wait for T2 to release the lock. Okay. And the condition number 2, okay, if the timestamp of T1 is smaller than the timestamp of T2, T2 is aborted. This one will be rollback. Okay, just like that. Okay, request write block for Y transaction and preempts the T2. Okay, they will take over the T2 and the T2 will be aborted. And the transaction will not be done. Okay, it needs to be rolled back. Deadlock detection and recovery. So how they are going to detect and recovery the deadlock? Okay, so the DBMS, okay, the database management system, okay, it allows deadlock to occur, but recognize it and breaks it. Okay, I mean to say they allow the deadlock to be happen. Okay, and when they know the deadlock to be occur, okay, to be happen, okay, it will recognize and break it. Okay. If don't know deadlock, mean to say everything will be okay lah. Okay, so they don't have to recognize and do the break things. Okay. So this one usually handled by the construction of wait for graph or WFG for short. Okay, and showing transaction dependencies. Okay, so they create a node for each transaction. Okay, like get the edge of Ti larger than this Tj, the Ti waiting to lock item locked by the Tj, something like that. Okay. So the deadlock exists if and only the wait for graph contain a cycle like this one. Okay. Because these are what we call it looping. Okay. So on waiting. Okay. So the wait for graph is created at regular intervals. Okay. So how is DBMS recognized when there is a looping like this? Okay, so now we look at versioning. Okay, optimistic approach to concurrency control. Okay, so increasing the concurrency. Okay, multiple transaction can read and write different version of same data item. Okay, the same data item but different version. Okay, so assumption is that simultaneous update will be infrequent. Okay, so each transaction can attempt an update as it wishes. So each of the user are able to do to modify okay, modify means to update the data. Okay, but the commit check is made to determine whether conflict has occurred. If yes, the transaction is rolled back and restarted. Okay. So meaning to say here, let's say you have 3 users doing the transaction. Okay, they're able to do the transaction until they commit their transaction, but at the end, okay, when the commit has been made by this 3 person, okay, they will this versioning they will check on the commit. Okay, if there is a conflict, then they will restart it back. Okay, meaning to say the transaction is not running, it is not success. Okay, it will become like this. Okay, so John and Marsha. Okay, John will do the transaction first. Okay, just the time frame over here, time period. Okay, John is the first one to hit the read balance. Okay, then after a period of time, then Marsha will do the same thing. Okay, so they already withdraw. John already withdraw 200, and now we know the balance is 800. But when Marsha is attempting to withdraw the 300, okay, what happens is it become rollback. Okay, because there is a clash on this thing. Okay, there is a clash according to the balance because Marsha see the balance 1000, but whenever it comes to this period of time, okay, when Marsha trying to withdraw 300, okay, what they call it, during this period of time, okay, Marsha will still believe that the balance is still 1000, but instead, John already withdraw 200 from the balance, okay, but it didn't show on Marsha monitor okay, and John commit, okay, what happened to Marsha? Transaction will not be success and it will roll back to the first one. Okay, roll back and going to restart the transaction. Okay, getting back to this new balance. Okay, so there are 3 phases of versioning. Okay, we read, validation, and write. Okay, so read. Okay, so reads value from database and stores them in local variables. Okay, so the updates are applied to a local copy of the data. Okay, so all the updates apply to a local copy. Okay, local copy only. Okay, so validation. For read-only transaction, okay, checks that the data read are still current values. For update transactions, okay, checks transaction leaves database in a consistent state. Okay, with serializability maintained. Okay. If not, the transaction is aborted and restart. Okay. That the validation phase is. And then the other one, right. Okay. For successful validation of update transactions, okay, the updates made to the local copy are applied to the database. Okay, so meaning to say everything that has been done here, everything is a local copy of the data only. It's not straight away right to the database. Okay, it's only applied to the database when everything is okay. Okay, and it will upload to the database and update over there. At first, everything will be for a local copy only, right? So the advantage, okay, this one, okay, is deadlock free. Okay, meaning to say they will not having the deadlock situation which they need to make. Okay, and it will maximize the parallelism. Okay, parallelism meaning to say all the user that do the transaction, okay, same time, say exactly at the same time. Okay, they will not having problem of deadlock like that. Okay, the only thing um, could happen is rollback and restart. Okay. So first one who did the commit are not having the problem to restart. But for the other, yes, of course they need to restart because the current balance, okay, let's say the balance is not updated. Okay. And the disadvantage of this versioning is rerun transaction if abort. Okay. And probability of conflict rises substantially at high loads. Okay, if a lot of users going into the same database, okay, doing the same transaction, okay, this one will be the disadvantage of versioning. Okay, because they keep on getting imports. Okay, because first one win. Okay, and then the rest, of course, they need to reboot. Okay, need to reboot back and need to reload. Okay, like that. Okay, and this may generate high loads, okay, on the network. Only on the network one person going into the database. All right, database recovery. Okay, so before we continue with this database recovery, so I believe let's take a rest for a while and then we continue with this database recovery. Okay, so let's have a quick break around 10 minutes. Okay, by 10 a.m. then we continue with this one. All right. All right, so let's take a break, everyone. All right, let's continue. Okay. All right, so everyone's ready. Okay, good. All right, so we're going to continue with the database recovery. Okay, to recovery the database. Okay. So types of failures that might happen. Okay, system crashes. Okay, and resulting in loss of main memory. Okay, media failures. Okay, this will result in loss of parts of the secondary storage. Okay, and also application software errors, natural physical disasters, carelessness or unintentional destruction of data or facilities. And it could be a sabotage. Okay, let's move. Okay, so the database management system, okay, okay, start at time t0, but fails at time tf. Okay, at this moment, the f could be anything. Okay. So the T1 and T6 have to be undone. And T1 and T6 have to be undone or to be rolled back to T0. Okay. Example, to undo any effects of the transaction or automaticity. Okay. So in absence of any other information, T2, T3, T4, and T5, this one, T2, T3, T4, T5, okay, have to be redone, roll forward, okay, to ensure the durability. Okay. So this one only T6 and T1 will be rolled back, but for T2, T3, T4, T5, okay, will be redone. Okay, redone means say straight away redone lah. Okay. Okay. Let's take a look at an example of data access with concurrent transaction. Okay, so these are the memory. Okay, so you just have to know what is memory and what is disk. Okay, this is where we save everything. Memory will be the temporary. Okay, so read operation. Okay, read X. Okay, read X. Okay, so find the address of the block or page that contains the record with the data item X. Item X. Okay. Transfer the block into a buffer. Okay, in main memory. So copy the value of X from the buffer into the program variable X. Okay, this is for a read operation. Okay, work area of T1. Okay, do this thing up. Okay, so in write operation, okay, this one and two are the same. Okay, so straight away to number 3, it will copy the value of the program variable Y into the buffer. Okay, so these are buffering or loading place. Okay, so it writes the buffer back to the block on disk. Okay, we put back this disk. Okay, it's an operation now. Okay, anything from this memory, they will put it in the loading place, which is this one buffer. Okay, buffer here is referred to loading places. Okay, loading place. Okay, loading area. Okay, before it gets to the destination. The destination here will be the disk itself. Okay, all the memory over here is everything is in the RAM. Okay. So this recovery facility that DBMS should provide, okay, will be this one, the backup mechanism. okay, which make periodic backup copies of database. Okay, logging facilities, okay, which keep track of current state of transaction in database changes. Next will be the checkpoint facility, okay, which enables updates to database in progress to be made permanent. And then there will be a recovery manager, okay, this one which allow the database management system to restore database to a consistent state following a failure. Okay. So let's take a look, is there any recovery to this? Okay, so let's take a look at this recovery facility. Okay, backup, of course, we need a backup. Okay, why do we need the backup is so that if anything happens, we still have a backup for it. Okay, so I believe all you guys know what this backup is. Logging facility is something like a log file, okay, to keep track, okay, which transaction, any changes made. Okay, because in the logging file, okay, they will keep track on every second. Okay, what happened during this period of time? Okay, is everything going fine, or is there an error on this period of time, something like that. Okay, checkpoint. Okay, checkpoint will be a point where you how to say, you pinpoint a certain period of time which you know that these are the safe state. Okay, I mean to say, when you roll back, you will roll back to the point that you have been, set the point. Okay, same thing like system recovery, okay, in your PC. Okay, sometimes if anything, let's say, okay, I just give an example. Okay, let's say when you install some of the software, and the software can cause your operating system crash or whatsoever, you are able to roll back the situation. Okay, so you're going to roll back at the point that you have set up to recover. Okay. But if you don't have the checkpoint, then it's either you want to format back your PC, or you have they call it the recovery file, then you can just okay, which is to be the recovery manager lah. Okay, it restore the database consistent, but this one it refers to the database recovery. Okay, you go back to the point that we have set. Okay, log file. Okay, it contains information about all updates to the database in regards just now. Okay, it's a transaction identifier. Okay, type of log record. Okay, there will be a transaction start, insert, update, delete, abort, commit. Okay, so identifier of data item affected by database action. Okay, is insert, delete, and update information. Okay, there is a before image of the data item and after image of the data. So, okay, so everything is recorded in the log. Okay, so let's say when you do a transaction, okay, they will know when you start, and you're going to insert something in the database, or modify, and to delete. Okay, cancel. Okay, everything has been recorded, okay, in the log record. Okay. Next, checkpoint. Okay, checkpointing. Okay, point of synchronization between database and log file. Okay, all buffers are forced returned to a secondary storage. Okay, we pinpoint the timing. Okay, which part. Okay, like that. Okay, so the steps. Okay, suspend execution of transaction temporarily. Okay, you force write modified buffer data to disk. Okay, anything that in the loading space, get into the disk. Okay, and write a checkpoint record to the log, set the log to the disk, and resume normal transaction execution. Okay, so the checkpoint record is created containing identifiers of all active transactions. Okay, so you need to pinpoint which time period. Okay, Okay, so database recovery. Okay, it's a recovery method. Okay, so recovery manager for the DBMS module that restores, okay, the database to a correct condition, okay, when a failure occurs, and then resumes processing user requests. Okay, so the recovery and restart procedures, okay, is mirroring, okay, switch between identical copies of databases. So meaning to say this mirroring actually is a type of particular. This one, if you are learning in computer hardware, okay, like that, okay, and you do this mirroring, okay, meaning to say you have, example, you have two hard disks, okay, which contain each of the disks. Let's say each of the hard disks is 10 gig, okay, 10 gig and 10 gig, okay, something like this one, okay, this one and these two, okay. This mirroring, what happens is, okay, whatever you save in this one, these two will mirror the process. Okay, so whatever you have in this one, these two will have the same thing in this one. So meaning to say, yeah, everything is being mirrored. So whenever this one fail, they will load from this second disk. That is this mirroring. Okay, restore and rerun, restore or rerun. Sorry. Okay, it's a reprocess transaction against the backup. Okay, and this one only done at the last resort. There is no other option. Okay, okay, backward recovery or rollback. Okay, apply before images. Okay, meaning to say apply before images. Okay, meaning to say going back to a time which you have not done any transaction yet, something like that. Okay, roll back. Okay, let's say let's say with this one I take an example of driver. Okay, your PC driver. Okay, let's say okay, I take an example of your graphic card. Okay, you have this graphic card and then you want to update the graphic card on top is the version, or there is an updates. When you click on the updates, so what happened with your operating system, it doesn't work fine. Okay, so what happened is you just roll back. Okay, there's a button to roll back now. Roll back before you install the new updates. Yeah. Okay, forward recovery, roll forward. Okay, apply after images. Okay, this one is preferable to restore or run. Okay, rollback. Okay, undo to unwanted changes to a database like I said before. Okay, so before images of the record that has been changed are applied to the database. Okay, and the database is returned to an early state. Okay, example, reverse the changes made by transaction that have been aborted or terminated term abnormally. Okay, the undo operation are performed in the reverse order to which that were returned to the log. Okay, that is roll back, roll backward, roll forward, forward recovery or redo. Okay, so this is a technique that starts with an early copy of a database. Okay, now database contain changes and there is an after image. Okay, the after image is the result of a good transaction. Okay, anything happen with this database, okay, you're not success of updating or something like that, and then you have another image over here of this one we call recovery. Okay, a recovery means a recovery not from the previous transaction or whatsoever. Okay, this one is something like images after the transaction. Okay, which is the good one. Okay, okay, putting into this DBMS. Okay, the database. Okay, you can say apply to the database, and the database is quickly moved forward to a later step instead of back step. Okay, So these are the example of recovery on how to recover. Okay. So these are the older, okay, these are the time frame. Okay. So beginning of the log has start, okay, something else, and then there is a short checkpoint, okay, we can go another checkpoint, okay, and you start commit, okay, again start, cycle, and then clear about, okay, and this start is about there is a crash, okay, so when we look at this one, T0 rollback, okay, during normal operation, again, we roll back to T0, okay, and this one, T0 rollback completed, and then T2 is incomplete and crash. Okay, you can see T0 stop it here. Okay, we roll back, okay, and at this moment, okay, T2 is incomplete and crash, okay, because the end of the lock crash over here. So the lock records aiding during recovery decide, okay. T2 rollback in undo pass. Okay, move back again to here. Alright. Okay. Something like this. Okay. This is only an example. Okay. Yeah. Transaction 0 and transaction 1 and transaction 2. Okay. Again, on this one, we do our roll forward phase. Okay. Find last checkpoint and record. Okay. And then scan forward from above. Okay. The checkpoint. Okay. Last checkpoint. Okay. Record. Whenever a record, okay, the transaction 1, okay, XJ, V1, V2, okay, is found, okay, redo it by writing V2 to J. Okay, to undo or roll back, okay, scan log forward from the end, okay, from the end of the log file to the first one. Okay, so whenever a log record is found, and perform undo by writing P1 to EJ. Okay, and write a log P1, XJ, and V1. Okay. So let's take a look at this one. Okay. When failure occurs, okay, so redo all transactions that committed since the checkpoint. Okay, and undo all transactions active at time of crash. Okay, so all transactions, okay, will be undo at the time of the crash. And this one will be redo, okay, since they have the checkpoint. Okay, so let's see with the checkpoint at the time TCC here, this checkpoint over here, the changes made by the T2 and T3 have been written to a secondary storage because this T2 and T3 transaction has already committed. Okay, so thus only redo for T4 because this one is unfinished, and T5 people are not able to finish, even starting also up there, okay, and they will redo. Okay, but for T1 and T6, okay, they will undo the transaction because T1 you can see the timeline over here, it has not commit anything yet, and yet T1 over here crash. Same goes to T6. Okay, even though because T6 they haven't finished anything yet, they have not commit. If you look at T4 and T5, both are this transaction already commit. They commit the transaction, but the thing is the checkpoint is in the middle here. Okay, the middle checkpoint. Okay, before it goes to crash on this period of time. Okay. So So aborted transaction, okay, causes human error, input or invalid data, hardware failure, and deadlock. So preferred recovery will roll back. Okay, the alternative roll forward is that just prior to abort. And these are the alternative, but the preferred one will be rollback. Incorrect data, but valid. Okay, valid data, but this is incorrect. Okay, so what are the causes? Okay, carelessness or unintentionally human mistake. Okay, only human mistake. And preferred recovery for this cause. Okay, rollback if the error is discovered soon enough. Okay, another alternative, okay, alternative one, compensating transaction through human intervention to correct the error if only few errors are occurred. Okay, this one, the alternative one, okay, need human intervention. Okay, not the database itself, okay, not the computer itself, the software itself. Okay, and the alternative two, reprocess a transaction from the most recent checkpoint before the error occurred. All right. System failure, the database impact. Okay, it caused by the power loss, operator error, loss of communication transmission, and system software failure. Okay. Normally, this one is hardware failure, okay, or not system failure could be the software itself. Okay, so type of recovery preferred is switch to a duplicate database. Okay, like I said, when you have the mirroring, okay, you will have the duplicate database. Okay. Okay. Another alternative here is rollback the transaction. Okay, see whether when you are rolling it back, it goes smoothly or not. Okay. And alternative two, restart from checkpoint. Database destruction, okay, causes disk drive failure. Head crash. This one they are mentioning about magnetic disk or your hard disk. Okay, disk failure or head crash or something like that. Okay, because they are using, if you are using hard drive, okay, there will be a pin, okay, pin on the disk. Okay, pin. Okay, but if you're using SSD, you just type on this one, disk drive failure. Okay. Okay, and then for this one, prefer recovery, switch to a duplicate database. Okay. Okay, so this already failed. Okay, all you need to do is just get another new disk and yeah, paste the recovery. Or if you have the mirroring, like I say, which one already? This one. Okay. If this one failed, you can say this one failed. You can say this one is faulty. Okay, so you can just use another duplicate disk. Okay, to run the database again. Okay. Alternative one, scroll forward if you have the image, okay, the image after. Alternative two, reprocess the transaction. Okay. So whichever is good. Okay, but just focus on the preferred recovery. Okay. If the disk drive is failure, don't push it. Okay. You might lose more data on it. Okay, and that's all for this chapter 8. Okay, so yeah, we're going to continue with the chapter 9. Okay, after this. Okay, so before we continue with the chapter 9, so let's have a quick break. Okay, around 10 to 15 minutes. Okay, so if you want to read more about this chapter 8, okay, you can look at the references here. All these references here is all the slide is now taken from this reference. Okay, the database system, a practical approach to design, implementation, and management, modern database management, and fundamentals of database system. Okay, and that's it for chapter 8. Okay, so let's take a break. Okay, going to continue this lecture at 10:40. All right, okay, 10:40. Okay, so let's take a break, everyone. All right, let's continue. All right, so we're getting into chapter 9, distribute database. All right, so let's get through this one. Okay, so we might cover this one a little only, okay, because we are running out of time. We still have 20 minutes, so let's get through to it. Okay, so these are the learning outcomes for this chapter 9. Okay, so I will upload this chapter 9 later, okay, after we're done with this session. Okay, so learning outcome for this chapter 9, okay, is for you just to able to describe the characteristic of distributed database environments, and also you must be able to explain the strategies and options for distributed database design. Number 3, be able to discuss data replication and partitioning. Number 4, be able to discuss the query processing in distributed database. And last one is to describe the distributed concurrency control. Okay? These are the learning outcomes that we need to achieve. Okay, so now let's take a look at the distributed database. Okay, so distributed database is a logical interrelated collection of shared data. Okay, and a description of this data. Okay, so physically distributed over a computer network. Okay, logically interrelated collection of shared data, but physically distributed over a computer network. So you can see over here, okay, how we have DB stands for the database. Okay, the database might be located at site 1, the other one is site 2, and the other one is site 4. And these three databases are connected through a network. Okay, a given site may have a local copy of all, part or none of a particular database. So this database can be accessed by people in site 3, site 4, site 2, or site 1. Okay? Because they are interconnected. Unless they are not connected, then yeah, only the person on site 1 can get into this database only, not from the other. Okay? Just because this one is connected through a network, and all the people in any site are able to get into those database. Centralized database. Okay, centralized database is a database that is located, stored, and maintained in a single location. Okay, you can see over here employee table, department location, project, and the works on. Okay, so when we look at this one, okay, all these tables are in the same location, same in, okay, might be in the same database. Okay, so you can look over here, the DB1 and DB2, okay, database 1 and database 2 is located at the central site. Okay, this is what we call it a centralized database because it's been in the same location. Okay, and site for San Francisco, Los Angeles, Atlanta, and New York is connected through a network to this central site. So people from this site, okay, like New York, Atlanta, or Los Angeles and San Francisco, okay, are going to the central site to get into this database. Okay. So we look at here, okay, another example, okay, distribute database. Okay, this one distribute database, centralized database. Okay, so we look at here. Okay, so all the employees, okay, for San Francisco, okay, will be in San Francisco site. For Los Angeles will be here. Los Angeles, Atlanta will be Atlanta, New York for New York, and this Chicago will be having all the information from this four sites in this Chicago headquarters. Okay, so anything that get update from this site be affected in this Chicago headquarters. Okay, the advantages of DDBMS. Okay, so this DDBMS stands for the dynamic, okay, dynamic database management systems. Okay, so it increases the reliability and availability. Even if a component fails, a distributed system will continue to function at some reduced level. Reduced level here meaning to say if one of the site fail, okay, they are still able to look at it because everything has been um, sent to the headquarters. Okay, might be any changes on here will not affect it here if there are lost connection. Okay, so local control over the data. So each site control its own data security, logging, and recovery. Okay, and then the user can access non-local data when needed. Okay, non-local data meaning to say if you are in the Atlanta and then you want to get into this New York database, you are able to do that one. Okay, okay, it says here user can access non-local data when needed. Okay, modular growth. Okay, easier and more economical to add another computer and data to distribute networks. Okay, and it lowered the communication cost. Okay, why? By data located closer to the point of use. Okay, lower communication cost means to say um, something like the network bandwidth. Okay, let's say you are in the Los Angeles. Okay, all you need to do is only update on your site. Okay, because whenever you update everything here, let's say in the Los Angeles, okay, all the updates will be transferred to Chicago headquarters, okay, automatically, rather than this user are getting into this EBMS on this headquarters and insert to update anything over here because it consumes more bandwidth. Okay, bandwidth is network. Okay, so um, it will be efficient if you do something over here which require no bandwidth at all because everything is local. Okay, only the updates are sent to the headquarters. Okay, and it will reduce the communication cost. Also, communication cost here is the bandwidth itself. Okay, I can say it's a bandwidth itself because if you need a faster connection, okay, it requires a lot of money. Okay, to get a quality connection. Okay, faster response for certain queries. Okay, data located closer to their point of use. Okay, how, how can we say that? Okay, let's say you are in the Los Angeles, and you only need to query about the Los Angeles stuff. Okay, then it will be easy to get because you will not get into this headquarters to get all the details. Okay, the query. The query is everything is in the Los Angeles. It's a local database. So it will be much more faster than me to get out from Los Angeles and get into Chicago, then come back to Los Angeles. Okay. Even if you do query in a local database, require a bit amount of time. Okay. But when you do query from Your headquarters will take you a lot of time to do that one. Okay. Okay, the disadvantages of this DBMS. Okay, software cost and complexity. And of course, in order to do these things, okay, it will expand the cost of the software. That's the software you need to purchase, and in order to use it also will be complex. Processing overhead, again, to ensure proper coordination among data at the different sites. Okay, it could be the processing overhead. Data integrity exposure, okay, harder to ensure that the integrity because of the increased complexity and need for coordination among data at different sites. Okay. Slower response for certain query. If data are not distributed properly, not located close to the pinpoint of use. Okay, like I said just now, okay, if you want to query something outside from the loss result, it will take times to do that one. Okay, but if you only query in the same site, then it should be no problem. Okay, so there are types of distributed database. Okay, homogeneous and heterogeneous. Right, so take a look at the homogeneous, okay, DBMS. Okay, so all sites use the same DBMS product. Okay, so your database could be Oracle, can be Microsoft Access, okay, it depends. But all the sites are using the same product, same brand. Okay, so the underlying operating system then can be mixture of the Linux, Windows, Unix, or etc. Okay, it's much easier to design and manage. Okay, an approach provides incremental growth and allow increase in performance. Okay, doesn't matter you are using Windows or any other operating system, but the DBMS product are the same. Okay, for heterogeneous DBMS, okay, site may run different DBMS product with a different data models. Okay, so occurs when sites have implemented their own databases and integration is considered better. Okay, so translation is required to allow for different hardware and or different DBMS product. The typical solution for this one is to use a gateway. Okay, gateway here means a translator. Okay, convert the language and model of each different DBMS into a language and model of the relational systems. Okay, so yeah, this will be a problem actually here when different site they are using different database product. Okay, and why some of them are using different type of product is because of cost. Okay, the software cost itself. Okay, because when we look at this one, the disadvantages, okay, the software cost complexity. Okay, so when they are using the different product for each site, okay, then you need to get through on this translation. Okay, getting more complicated. But of course, yeah, if you think about the future, and that day, okay, you plan on having another site, okay, in the near future or the future like that, okay. So you should think about what type of database management system you should use. Okay. Sometimes it might be the database. Let's say you're using, let's say Microsoft Access, and then after 5 years, you found out that this Microsoft Access is not acceptable for your needs, and then you need to upgrade to other product. Okay, let's say, okay, say you're in this iPhone. Okay, I don't want to use Windows product anymore. Okay, Microsoft Access like that. Okay, I want to change this one. But what happened to the other side? Okay, might be the other side are okay with the Microsoft Access. Okay, okay, no problem at all. Okay, and you have to know also. Okay, when you are purchasing this window access, okay, they will have a license, and then the license also is not said it will be permanent license. Okay. Some of the license need to be upgrade, or not to say upgrade, I mean to say to extend the license, okay, and then of course you need to pay. Okay. And that's why sometimes they are changing the DBMS software, the product. Okay. They're going into a cheaper and convenience to use. Okay. And of course for the, what they call it, the troubleshooting. So one more, the support. Okay, the support also. Okay. So everything here are using a licensed product. Okay, they are not going to use pirate software, because if they are detected using a pirate software, they are the penalty for them. I think they will get a penalty. Okay. Only in business world, okay, you need to use genuine product. Okay, if you're detected of using pirate product, then of course you will get fined. But it will mean okay if you're using pirate for home use only, for work purpose, okay, for business purpose, okay, and we look all into it. Okay, when the audit comes up. All right. So I believe for this distributed data storage number two, this one will be continuing next week, right? Okay. So yeah, I think we're going to stop chapter 9 at this page 11. All right. Okay. So far, yeah. Well, this further will be the presentation. Okay. So presentation will be start with group number 1. Okay. Group number 1 and group number 2 just get ready. Okay. If we have enough time, then we can start away to group number 2. Okay. So is there anything else I just want to ask, okay, before we end this session? Anything? No questions so far. All right, thank you, Noel. So how about the others? Yes, I will stop this presentation. Okay. So before we end this session, okay, I think I need you guys to turn on your camera, please, and take a look photo now. Take a photo with you guys. Okay. You can use your handphone, you can use if you are if you're having problem with your webcam, then you just use your phone, okay? Capture picture of you guys. Right? Alright, so please turn on your webcam, everyone. Never mind, you can use your handphone also. Just use your phone, okay, Jonathan? Phone pictures. Okay, is there any of you who's not present here? Everyone is here, right? 15%, let me check. Okay, who's are not present? Who is absent? Anyone from your group? 1 all present. Group 2. Okay, okay. Is here problem with the electric again? Okay, so who's not here? Celine, turn on your webcam. Nathan, where's Nathan? Nathan here, okay. Noel, are you there, Noel? Okay, Noel's there. Jeremiah, yeah, Jeremiah's there. Okay, so I believe that's all. Hold on, let me screen all of you. Right. Thank you, everyone. I think that's all for today. So I'll be seeing you this Friday. Okay. So make sure get ready for the presentation. Group 1 and Group 2, please get ready. Okay. All right. Thank you, everyone.